Okay, we are at the end of the unit, and you are going to have a fossil tool design challenge. Now, remember, you are an engineer, and in this project, you are going to be solving a problem. Engineers are creative problem solvers, and they work in teams and don't give up. And remember, we are also going to go through the engineering design process. Your group will be going through the process to solve the problem. And the process looks something like ask, research, plan, build, test, and share. And you're going to have criteria, which are the guidelines for the project. And you've met your guidelines and you know you've completed the challenge. Constraints, on the other hand, are different. They are the limitations and restrictions of the STEM challenge, and some examples can be time and resources. Well, what's the problem for this design challenge? So it looks like you have found a fossil in your backyard. It is precious, so you want to make sure you uncover the bones safely without damaging them. You can't use a knife because it might scratch the surface. You can't smash it, it might break it. Your tool must have two different functions. Some examples of tools are brushes, picks, floss, and tweezers. And remember, you know that fossils are the remains of plants and animals that lived long ago. They are often found in layers of rocks, and these fossils can get covered in sediment like dirt or sand, and then they can get compressed. How can you build a tool to uncover fossils? This project is going to have three different criterions. The first criterion is that your tool must be built with items from around the home or the classroom. The second one is that it can be any type of tool. And third, it must have two functions or two parts. If you look over here, you see that this design has two parts. This part on the bottom is kind of like a sifter through rocks and debris, and the top part is like a tweezers. Your design is also going to have constraints, and this may be different depending on your teacher, but you will have 60 minutes to build, and you can use up to 5 materials. You're not able to use tape or any adhesives like glue. So let's get into the first step, ask. In this step, you will be individually writing down what is the problem and how to solve it. How do you know it's going to be successful? Once you know the problem you are solving, you're going to do some research. And in this step, you will think about what you've already learned about rocks, layers, fossils, paleontology, and do more research on the internet. In the next step, you are going to be planning. So you will sit with your group and you will make a plan as to what you are going to do when the time comes when you're building. And that plan can look like a sketch of what the final product should look like. It could be what materials you will need, what the steps will be when you build it, and then you are ready to build. When you are building, your group will have jobs and you will all partake in building your design. And you know what comes after build? It's going to be testing your build. Your group will test the build that is built. You will make sure you're doing observations, recording the responses, and thinking about your reflections. Once you think about your reflections, you will in fact share these with the rest of the group. And this can look like a presentation or writing on paper or on the computer. And you're basically thinking about questions such as what can be approved, what design decisions were effective, and at the end, your teacher might have an assessment for you along with the rubric.